This is the fifth and final video for Chapter 1. During this video, I'll discuss the scientific method. So, how do scientists study the universe around us? The scientific method I'll describe here is a generalization. While research often follows a similar path, remember that there's no single right way to conduct science. Typically, the first step is to make observations on something in which we're interested. These observations can be made with or without fancy equipment. They can be accidental or collected following extensive planning and effort. Reading publications written by others can also provide interesting observations. After making observations, the next step usually involves forming a hypothesis. A hypothesis provides a possible explanation for your observations. A hypothesis might be called an educated guess, with heavy emphasis on the educated. While hypotheses are tentative explanations, they should be based on all the information we currently have on a subject. To be useful scientifically, the hypothesis must be testable. Creation of hypotheses utilizes inductive reasoning. We collect isolated facts and use them to create some cohesive statement. To the layperson, the terms theory and hypothesis are often used as synonyms. That's not how scientists use the words. Hypotheses are explanations that have not been thoroughly tested. They should be viewed with skepticism. In contrast, a theory is an explanation that has been thoroughly tested in many different ways by many different people. And so far, they've always been found to be true. Theories may often include several related hypotheses. Even though they've been thoroughly tested, theories should not be considered as absolutes. Statements that are accepted as fact are called laws or principles. We're not going to talk about many laws in biology, in part because there's still a lot about biology left to be discovered. Back to our scientific method. After formulating a testable hypothesis, the next step is to test that hypothesis using experiments. Experiments are how we determine if a hypothesis is accurate or not. Experimental design often utilizes deductive reasoning, sometimes called if-then reasoning. Based on our hypothesis, we can make one or more predictions on what we expect to happen during our experiment. If the hypothesis is true, then the actual observation should match our predictions. There are many things which can affect an experiment. These factors are called variables. Can you think of some examples? When I say controls, I don't mean knobs like that you would use to control a device. Instead, I'm referring to factors which could potentially influence an experiment that are going to be kept constant. We're not going to allow them to change during the course of our experiment. The controls are variables that we are currently not testing. Generally, experiments are designed so that only one variable, the experimental variable, is allowed to change at a time. Why is this important? Please come prepared to discuss this in class. Experiments usually include a control group, one that receives the same treatment as the other groups, except the experimental variable is also kept constant. Why is that important? Sometimes the experimental variable, the one that we're testing, is also called the independent variable. This is the factor that we decide it's going to change. We determine its value. We then want to measure how changing the experimental variable affects the outcome of our experiment. The response that we measure is called the dependent or response variable. After performing an experiment, it's time to objectively evaluate the results. Objective evaluation is perhaps the most important part of the scientific method. We must take every precaution to make sure that our biases don't cloud our judgment in deciding how we interpret our experimental results. Two examples of how scientists maintain objectivity are peer review and statistics. We'll discuss both of these in class. The fifth step is to make a decision concerning the results and evaluation of our experiment. Is our hypothesis accurate? Do the results support it completely? Even if the answer is yes, our next step is to repeat the process. We may want to repeat exactly the same experiment, or make modifications to test the hypothesis in another way. Hopefully other scientists will become interested and test our hypothesis themselves. If you'd like to explore more about the scientific method, I'd highly recommend this website. To review, remember that the initial formulation of a hypothesis typically uses inductive reasoning. We gather bits of isolated information and try to make sense out of them. We look for a generalized statement that explains our observations. Testing a hypothesis uses deductive reasonings. If our hypothesis is correct, then we expect to see these results in our experiment. This concludes the Chapter 1 videos. Don't forget to take the quiz on Blackboard.